Now let's see some of the examples based on permutations and combinations. In a party, there are 101 people. If everyone shakes hand with every other person, then how many handshakes are possible? Now here we know that for one handshake we need two people. So therefore effectively we have to find out how many ways are there to select a pair of two people out of 101 people. So therefore, as per the definition of combination, that number is nothing but 101 C2. So that is equal to 101 into 100 whole divided by 2, which comes to 5050. Now moving ahead to the next question. There are n points in a plane such that no three of them are collinear. Find the number of straight lines and triangles that can be drawn by joining these points. Now here also, like the previous example, if we see, one straight line is defined by two distinct points. So therefore, to know the number of straight lines that can be drawn, we have to find out how many ways are there to select 2 points out of total n points. So therefore, which can be done in NC 2 ways. Similarly, we can see that if we want to know how many triangles are possible to draw, for one triangle we need 3 distinct points, that is the 3 points which are not collinear. So out of n points, the 3 points can be selected in NC3 ways. So therefore, that is the number of triangles that can be drawn by joining the given n points. Let us move ahead to the next question. How many diagonals are there in an n-sided polygon? So here let's consider some polygon, not specifically of any particular side. Now by diagonal we mean a particular vertex is joined with some another vertex, assuming that the two vertices are not adjacent. If they are adjacent vertices, then that would become the side of the polygon and not the diagonal. So as we see, whether it's a side or a diagonal, both are basically the straight lines. So out of n points of the polygon, in general we can select 2 points in NC2 ways. So that gives the total number of lines that can be drawn from the n vertices of a polygon. But out of these lines, we can see that the vertices which are adjacent to each other, they will form a side which is not a diagonal. So therefore, we have to subtract the n sides of the polygon. So therefore, NC2 minus n is the number of diagonals that are present in the n-sided polygon. So we may simplify this further using the formula. So NC2 is nothing but n into n minus 1 upon 2 minus n. So if we take n by 2 common, then in the bracket we will have n minus 1 minus 2 remaining. So which turns out to n by 2 into n by 3. So that's the final answer. Let's go to the next question. There are 10 points in a plane of which 4 are collinear. How many straight lines and triangles can be drawn by joining these points? Now here there is an additional restriction that 4 points of the given 10 points are collinear. Now let's consider the first sub question, that is we want to find out how many straight lines can be drawn. Now if we assume that the 10 points were such that no three of them are collinear. So if we consider that particular case, then in that case the number of straight lines would have been 10C2, because that's the number of ways of selecting 2 points from 10 points. But in the given problem we have 4 of the points to be collinear. So that means if those 4 points were not collinear, then they would have contributed to 4C2 number of lines, which are not present because they are collinear. So therefore we have to subtract 4C2 from 10C2. But as you can see, the 4 points, since they are collinear, effectively they still form one line. So therefore we must add 1 to this particular answer. So which gives us the final answer of total number of straight lines. So on simplifying we will get 10 into 9 upon 2 minus 4 into 3 upon 2 plus 1. So which is equal to 45 minus 6 plus 1. So therefore that turns out to 40. Now if you consider the second question, that is, how many triangles are possible to draw from this set of given points. Now we use the similar approach to count the total number of triangles. That is, if all the 10 points were such that no set of 3 points are collinear, then they would have contributed to 10C3 number of triangles. But since 4 points are collinear, effectively the 4C3 number of triangles do not now exist, which would have otherwise existed. So therefore we must subtract 4C3 from 10C3. And 4 points being collinear itself does not form any triangle, so there is nothing to add finally. So therefore this is the final answer and we have to simplify it. So 10C3 is nothing but 10 into 9 into 8 whole upon 3 factorial, which is 6, minus 4C3 is nothing but 4, because 4C3 is same as 4C1. So calculating further, it is 120 minus 4, which turns out to 160. So that's the final answer. Let's go to another question. A set of 6 parallel lines is cut by another set of 5 parallel lines. What is the total number of parallelograms that can be formed using them? So here let's consider we are given a set of 6 parallel lines which is intersected by a set of 5 parallel lines. And now you can see that various different parallelograms can be formed by considering different pairs of lines from both the sets. So if we see, out of the first set we need to select any 2, which can be done in 6C2 ways. And out of the second set of 5 lines, once again we want to have any 2 lines which can serve as the opposite sides, so which can be done in 5C2 ways. And as we want obviously both the pairs of opposite sides, so therefore total number of parallelograms is nothing but the product of these two numbers, which is 6C2 into 5C2. So 6C2 is nothing but 15 and 5C2 is nothing but 10. So therefore which turns out to 150. That's the total number of parallelograms which can be formed using these lines. Now let's see one more question. Given 10 different consonants and 4 different vowels, how many different words can be formed if one word consists of 3 consonants and 2 vowels? Now here we'll assume that the repetition of letters is not there. Now if we imagine the word is given to consist of 3 consonants and 2 vowels, so in all we have to form the words of 5 letters each. But if we see, the 3 consonants are to be taken from 10 consonants. So out of the 10 consonants, we have to take 3 consonants. So that means the first step is to select the 3 consonants out of 10 consonants, which can be done in 10 C3 ways. Similarly, out of 4 vowels, we have to select 2 vowels, which can be done in 4 C2 ways. So therefore, since we want both vowels and consonants in a word, the total number of ways of selecting 3 consonants and 2 vowels is 10 C3 multiplied by 4 C2. So remember that this particular answer is just the number of ways of selecting 5 required letters. Now having selected those, these 5 letters can arrange among themselves in 5 factorial ways. So therefore the total number of words that can be formed is nothing but 10 C3 into 4 C2 into 5 factorial, which is the final answer.